So in case you're wondering where the title comes from, how many of you have seen the movie The Good, the Bad, and the Ugly? Oh my word, I'm surprised. I'd never seen it until the flight over here. I watched it on my laptop. Well, at least I've made amends now. All right, so this is a spaghetti western from 1966. The Italian actors said their lines in Italian, the American actors said their lines in English, and they just dubbed the opposite language for each release. So I thought, if things go bad, just pretend that I'm speaking Italian and dubbing myself in English. All right, so just a little background about where I'm coming from, my perspective, how I came to R. I started out my career working in math. I then left academia, became a software developer, and more recently have come to doing statistical computing. So I have sort of an outsider's perspective on statistics and the R language. And I've written a little bit of code in maybe a dozen languages, and R has been the hardest one for me to learn. Not because it's an intrinsically hard language. If you know nothing and you pick up R, then you just learn it. But if you know other things, R is just kind of strange, and you kind of want to make it into something it's not, and it's kind of hard to learn. You don't learn R the same way you learn Perl or Java or something. The right questions to ask is not, okay, how do I do loops? What are the data types? How do the classes work? That is not the way to learn R. In fact, that information is kind of hard to find out, and a lot of the people who use R the most probably couldn't answer those questions. R is a domain-specific language, and so you have to understand the domain. Learning R purely as a language would be like learning PHP as a language without being interested in web development, or learning SQL as a language. Okay, what are the data types? What are the structures and like this? I don't care about databases. I just want to learn the SQL as a language. Okay, that's kind of what it would be like. That was my mindset coming to R. Okay, I've learned programming languages before. I'm going to apply my standard template, and R didn't fit. So what is R? It's an open source statistical language. And you may be wondering, why does statistics need its own language? We'll get to that. It's the de facto standard for statistical research. Now, not statistics in general, not statistical practice, but more statistical research. The people who are doing standard statistics, applying well-known methods to well-known problems, probably use something else, like maybe SAS. But the people who are doing research into statistical methods are using R. It grew out of the S language, S for statistics. That makes more sense than R. What does R stand for? It's just S minus minus, I guess. So it grew out of the project from 1976 and then revised in '88 from Bell Labs. So the language is influenced by Scheme and by Fortran. We just think, that's kind of a weird mixture. How can you be influenced by both? R was first written in either Scheme or Lisp, I forget which, and had this Scheme-like syntax, but then it became imperative to have compatibility with S that had more Fortran-ish syntax, and so R adopted that. And so you can also see some Fortran influence, like array indices start at 1. And matrices are stored by columns, all like Fortran. And as Dennis Ritchie said about C, it's quirky, flawed, and an enormous success. I would say compared to C, it's even quirkier, even more flawed, but very successful in its niche. Okay, so really, what is R? What I've given you before is just kind of the standard Wikipedia article. This is what blah, blah, blah. But to explain this, I want to share a quote from a science fiction novel, The Canticle for Leibowitz. He says, "You don't have a soul, doctor. You are a soul. You have a body, temporarily." So my epiphany in trying to understand what R is all about is that R is not a language. R has a language. R is an environment for doing statistical kind of work, and it has a language. It's sort of like VBA. Excel has a language, but studying that language in isolation, wanting to study VBA not to program Excel is just kind of strange. Or another example might be Emacs. Emacs has a programming language, Emacs Lisp, a very old dialect of Lisp that I don't think many people love. It's a full programming language. You could write a web server in Emacs Lisp, I suppose, though I doubt anybody has. I shouldn't say that. You never should say that. Damien's up there thinking, well, I'll do it. I was like, and I'll do it only using characters with straight lines. No, but I think a lot of people think of Emacs Lisp as the price you pay for getting to the functionality of Emacs. I think R is sort of like that. There's an enormous amount of functionality, and the R language is the way you glue it together. So just how popular is R? Here's an example from a data analysis competition, what languages people used. Of course, R came out the most popular. And if you'll notice, sort of mainstream systems. I'm sorry? Oh, it has? Oh, okay. Good for them. All right. So if you look left to right, you have to go pretty far down before you get general purpose languages like Python kind of in the middle, C++, Java at the far end. So people are not using system languages for doing statistical analysis. They're not even using mathematical languages. Notice Mathematica is pretty far down on the list. Now, another data point. This was from a survey in Bioinformatics, where R came out on top. But I'll have to say something to explain why I think Perl is ranked so high here. Bioinformatics means different things to different people. It's a subset of computer science to some. It's a subset of statistics to some. It's, who knows, to others. So some people who come under the umbrella of biostatistics are doing a lot of file munging. So a lot of people use Perl for processing DNA sequences as strings. And I would imagine that's what accounts for the popularity of Perl here. The people who are doing statistics within bioinformatics are largely using R. Okay, so what's it like to use R? Well, here's a quote. Actually, using R is a bit akin to smoking. The beginning is difficult. One may get headaches and even gag the first few times. But in the long run, it becomes pleasurable and even addictive. Yet deep down, for those willing to be honest, there's something not fully healthy about it. Another comparison from Drew Conway and John Miles White, their recent book on machine learning. R has a unique and somewhat prickly syntax and tends to have a steeper learning curve than other languages. Okay, so if R makes you gag and it has prickly syntax, why do people like it? Well, as someone from Google said, the best thing about R is that it's written by statisticians. The worst thing about R is that it's written by statisticians. Okay, so to understand R, you really need to understand a little bit about what statisticians are like. And they have a very different view of the world than programmers. They may be programming in the sense that they are spending their days in front of a monitor, typing in things and running things. But they see the world very differently. And I mean, if you did a functional MRI of a programmer sitting at a computer and a statistician sitting at a computer, different parts of the brain light up because they have very different views of the world. And if you're not familiar with statistics, you may be surprised that it's actually quite different from math. You think, well, it's just a branch of math, but really it's very different. As sort of an expatriate mathematician living in a stat department, I can tell you that it's taken a long time to learn the lingo, different jargon for everything, different perspective on what is acceptable, what's not. And so you don't see statisticians using languages like Mathematica. They're very popular in math departments, like we saw on the previous slides, not so much in statistics. And a lot of people in statistics learn R as they learn statistics. And if you go looking for a book on R, you'll probably find a book on statistics with R. I know of only one book that I'll mention at the end that's really about R as a programming language, because that's not how most people think of it. Most people learn the R to carry out concepts as they learn them in statistics. And so the R programming language becomes synonymous with the statistical concepts to some extent, and it becomes unthinkable to use anything else. So, R is a domain-specific language, and to understand a domain-specific language, you have to understand the domain. You start with the domain, not the language. So the alternative to R is not something like Python or C#, or the alternative is SAS. So using a mainstream programming language is literally out of the question for most statisticians. If they didn't use R, they would use another statistical language. And often people who know R only know R, and they love their domain-specific language, and they use it for things outside the domain. I'm sure somebody's written a web server in R just like they've written one in Emacs Lisp. In fact, I answered some question on, I guess it was Stack Overflow, about R, and said, well, you'd never use R for a web server, you know, you'd use it for this. And then somebody wrote back, well, I've implemented a web server in R. Like, okay. So why does statistics need its own DSL? Well, for one thing, I mean, a pretty basic thing, you want statistical functions to be accessible. If you could imagine how a statistician would feel using C# and, say, writing math.log every time they have to take a logarithm, it would be like having to use conditional.if or branch dot, or whatever in your language. It gets to be really annoying. Data often comes in tables, and so table manipulation is fundamental, baked into the language because it's something that happens so often. Vector operations. Everything in statistics is vectorized because you have multiple observations. You have observations on multiple things, multiple people, multiple cats, whatever, and those are your vectors. So everything is vector-oriented. Missing data is a fact of life. Any real data set has missing data, and so you want your language to handle that smoothly, and not just like, oh my gosh, we've got missing data, what are we going to do? Throw an exception, call the police. You need to have a language that doesn't freak out with missing data. And just like something like Perl has patterns for text munging, R has patterns for common statistical tasks, and we'll look at a little bit of that in a minute. Okay, some advantages of R. Python people like to say Python comes batteries included, meaning you download Python and you've got everything you need to get started. Well, that may be true for some kinds of Python programming, but if you're doing statistical computing in Python, it's not batteries included. You start with the Python language, you use matplotlib for plotting things, you use scipy if you need mathematical functions, you use IPython as a shell. So really, that's more of the typical Python environment for scientific computing. R is not like that. You open up R, you have all these things in one giant namespace. Everything that you're likely to need is right there, if you're doing that kind of work. If you're not doing that kind of work, you wonder why things are missing. Okay. R is designed for interactive data analysis. It's not intended, was never intended for crunching enormous data sets. It's very much meant for someone who starts with a data set, plays around with it, let me see how this works, what if I plot this against this, that sort of noodling around. And it's very good at that. It's easier to program than some of its competitors. I haven't programmed SAS, but from what I understand, the language is about as sophisticated as DOS batch files, where it's really more of a macro language than a traditional programming language. So that would account for why people who are happy with what comes shipping with SAS use SAS. People who are needing to write their own stuff tend to gravitate toward R. Of course, R is open source, which is a bigger deal than you might imagine. Like at my institution, we're flush with cash. We can buy software, but it's tedious to buy software. The nice thing about open source is not saving money, it's avoiding the bureaucracy of getting a purchase order. And the same is true around the world. So wherever you have a collaborator, they can also download it without going through their bureaucracy. Okay. And you can imagine if you're dealing with data all the time, you want to optimize operations like querying and filtering because it's something you're going to do a lot. We'll get to linear regression in a couple examples here. So as an example of how you can work with the vectors in R, suppose you have null elements and you want to set them to 0. You have a nice succinct notation that says in the array X, those elements that are NAs, set them to 0. Or you can have more complicated expressions inside your index operator. You could say, for those elements of X whose corresponding index in Y corresponds to a value of Y that is bigger than 7, select those things and take the log of them. So this kind of notation allows for some very succinct, tight programs. It's also bewildering if you've never seen this before. So another example, linear regression is a very common task in statistics. You have some data you want to see, well, what kind of line could I fit to it? So let's imagine a fairly complicated scenario here. We have 3 independent variables, x, y, and z. We want to fit a linear model to these, and we want to include some interaction terms, meaning we don't just want x, y, and z as independent variables. We also want to consider x, y, or y, z. But we don't want to consider x, z for whatever reason. So we want to build this kind of linear equation. We want to find a least squares fit to it. We want to look at different residuals and stuff like that. Well, it's very succinct in R. R's linear regression notation is analogous to regular expressions for text munging. A statistician would do something like this as often as other people would grep on something. And so you have this kind of sub-language within the language that makes these things easy to express. So in a little more detail, you're fitting this set of 6 variables. So when it says x plus y plus z squared, that does not mean literally interpret that as a polynomial and square it. It doesn't mean that at all. It says this is shorthand for saying I want to include the variables x, y, and z, and I also want to include products of pairs, but I don't want to consider the x, z, that's what the minus at the end means, and implicitly there's a constant term, a. So very nice, succinct notation for a lengthy problem to describe. I'm sorry, in SAS you would do what? But your nose will be bleeding, okay. Okay. So here's a simple regression example. This was some data on butterflies looking at the effect of tannins in their diet on how well they grew. So I read in a text file that has my data. I'm telling it header equals true, meaning interpret the first line of the file as headers for the columns. When I say attach data, I'm saying I want to use the column headings as variable names. And I say, just to make sure I have what I think I have, let me say names, and it prints out that. Okay, then all the code necessary to fit a line to that data is model equals build a linear model regressing growth on tannins. And when you do, you get, if you look at the summary, you get a copious amount of data. You don't just get the the slope and intercept, you get far more than that. You get these p-values for the coefficients, you get residuals, you get all kinds of detail that you might want to see. All this is contained in an object. So when I say summary, it's printing an object. But if I were just interested in pieces of this, I could say model $, R uses a $, where you might expect a dot, like model $, this or that, to get to pieces of this object that represents the regression output. Now, another example, we'll look at a data set that comes with R. When you download R, it comes with several data sets. These are sort of like the equivalent of the Microsoft Northwind database. You know, there's some standard data sets that people use in examples. And one is this motor trend data from 1974, looking at, among other things, mileage and weight and whether something has manual or automatic transmission. So you can call help on this data set, and this will show you something like this. And if you look at the data, there's 12 columns. The two that we're interested in, or three, we're interested in weight and the gas mileage and whether the transmission is standard or automatic. So here's an example of an analysis of this data. So you have one line for automatic transmissions, the red line, the steeper bluish line for manual transmissions. You not only fit the lines to the data, you plot the data. These gray bands around the lines represent uncertainty. You get this nice gray background with white grid lines so that the grid is there, it's visible, but it's not real obvious. It kind of fades into the background, doesn't obscure the data. And here's the code for producing that. The code is very declarative. So I tell it what data I want. I'm using a library, ggplot2 by Hadley Wickham. It's a very nice library. I'm telling it transmission is a factor. That means it's some data that I'm treating as categories. When I see a 0 and a 1 in the file, that doesn't mean no transmission or one transmission. It means these are two categories that I'm looking at. So inside the plotting routine, I tell it I want to plot weight and miles per gallon from the data set MT cars. And I want to color code my data and show it as points. I'm going to fit a linear model, that's the LM. X tilde y says I want to plot y as a function of x, and so forth. Okay, some language features. R is dynamically typed. It has first-class functions, has closures, so you can pass a function as an argument to a function, that sort of thing. It has an object system. In fact, it has two object systems, one called S3 and one called S4, whereas S3, the older system, is sort of Perl-like, where you have a list and you bless it into an object. It's very permissive, convenient, loosey-goosey. The S4 object system is more rigorous, where you have to say what your fields are, and if you type in something that's not a field, you'll get a warning. Well, that's not the case with the older system. Neither one is going away anytime soon. The majority of objects are using S3, the older system. S4 is newer. It plays better with interfacing to other languages like C. Both in common use, but the older system is still more popular. And in fact, if you look at Google's style guide for R, they say avoid S4 classes. So, R is vector-oriented, for better or for worse. There are only vectors in the language. There are no numbers. If you type a 7, that is a vector of length 1 containing the number 7. So everything is a vector, for better or for worse. For better, it's very convenient to just say x plus y, and it sums the components. For worse, when you get something, you say, well, is this thing a number? I mean, i.e., does it have length 1 or does it have a length more than 1? So how should I treat it? And everything is passed by value. That can reduce mistakes, but it can also lead to a lot of copying. And everything is nullable, because we said, it's important in a statistical language to have the ability to deal with missing data. Well, you can deal with missing data two ways in R. You have an NA and you have a null. So an NA means I don't know. This has a value, it makes sense, I just don't know what that value is. So you have sort of this three-state logic. You could also have an unknown, you also have a null that means pretend I don't exist. It's like the line from Harry Potter where he says, I'll be in my room making no noise and pretending I don't exist. So if in some context, when you see null, the function will just ignore it as if it's not there. But if you see an NA, it depends on what you've told it. So do I ignore NAs or do I take them into account? All right, so an example of vectorization. Suppose I want to generate 1 million random variables, random samples by a normal distribution. R norm does that. So X contains 1 million random samples from a standard normal, and then I take their sum. This idea of pre-allocating a vector of everything that you need is good R style, but it would be poor C style because it's wasting memory. So if you're a C programmer coming to R, you might say, well, this is a bad way to do things. Yeah, it's tight code, but I'm going to be clever. I'm going to generate one random value at a time and add that to my sum, and I'm going to save allocating all this memory. Well, the second example runs 25 times slower than the first example. So what's bad practice in R is good practice in C and languages like that, and vice versa. So the people I've worked with who've learned R first and then come to a newer language, they write like the first example. They save everything before they do anything with it. And you have to say, no, you don't have to do that here. In R, you don't have to do that, but you almost have to do that because it's more efficient. For loops are very inefficient in R. Anytime you complain about the efficiency of R, the first thing someone will tell you, well, have you gotten rid of your for loops? Which is really kind of strange to think of a programming language that discourages for loops. I mean, not just that sometimes you don't need them, but you really don't even want to use them if you can avoid it. All right, so some of the drawbacks. R is slow. So just to give a number, maybe 100 times slower than C++, but it varies. If you have naively written code, maybe it's 1,000 times slower, or maybe it's twice as slow. It can vary tremendously depending on what you're doing. A lot of R is written in C in the back end, and if you're passing a large amount of work to do in C that it chews on before it spits back, it might be pretty efficient. But if a lot of the work is actually happening in R, it could be very inefficient. Tool support is a real problem. If you're coming from Visual Studio and this is your expectation of what language tools should be, R is about 20 years behind. It's starting to get some of the tools that we took for granted about a couple decades ago. Safety. R is designed for interactive use. Is not designed for production, and these are intention. There are a lot of things that it lets you get away with, assuming that you're interactively dealing with a data set, and you'll know if you've done something wrong. So who am I to complain? So that's what you said, I guess that's what you meant, and it'll let you do that. So like if you want to assign a value to one of the language's keywords, well, I guess that's what you meant. So problem with all this is people use R outside of its sweet spot. A lot of people only know R, so they use it for whatever task they have. All right. So if you want to learn more about some of the darker spots of R, there's a report called the R Inferno that says, if you believe you're in R hell, here is your guide. So it's 126 pages. It's sort of modeled on Dante's Inferno. There's kind of medieval artwork in it and so forth. But it has a lot of detailed information about odd corners of R and how to deal with them. All right, so the book I wish somebody would write is R, The Good Parts. I mean, if you're familiar with JavaScript, The Good Parts, this is a great book. Crockford takes JavaScript and takes a very cold eye view of it. These are features that are just bad. But inside JavaScript, there's a really nice language, and here's what I think that is. Here's the subset that I think is the good language inside of JavaScript. Well, I wish someone would write such a book for R. There are a lot of things that R does really well. There are landmines in R, like there are landmines in JavaScript. The languages are similar in that way, in that people use both languages before learning them, and there's pitfalls for the unwary. So whenever I talk about this book, I have to show this picture. There's the JavaScript on the left, and then there's the good parts, the little book on the... Okay, so some lessons from R. Data analysis is very different from system programming. More different than you might think. People will put up with a lot to get their work done. If you point out some of the problems with R, it has this weirdness, has this fails silently, this doesn't work. People say, yeah, but I gotta get my work done. I don't care how elegant your programming language is, I can't get my work done with it, so I'm not gonna consider it. And people will use a familiar tool if at all possible. Okay, so some resources for R. You can download R from the R project, r-project.org. I've written a guide that is a sort of a programmer's view of R. If you've written C++, Java, Perl, these common languages, this tells you some of the things that you might find surprising when you first look at R. And this is the book I mentioned earlier. The only book that I know of that treats R as a programming language is The Art of R Programming. This is a No Starch Press book that came out maybe a year ago. I forget. It's fairly recent. But it's a good introduction if you want sort of a programmer's eye view of R. And on Twitter, there's an account, rlangtip. I started this some time ago with 1 tip a day on R, and then I turned it over to some other people who knew more about R to let them run it, and they've kept it going and growing. All right, so that's it for me. Questions? Yes, sir. Right. The problem is not binary compatibility. You can get other languages to call R, or get R to call other language. Just the problem is more cultural compatibility. For example, you're building a C# interface on top of R, or you pass it in a vector. Or maybe worse, the other way around. So you're writing C++, somebody passes you an R vector. Well, this is a vector of numbers, you assume it has numbers in it. Well, not necessarily. Maybe it has NAs, maybe it has nulls. So if somebody says, I've written this code, it's just great, here, use it, you got to watch out for these kind of things. Or, for example, what does it do on an error? Well, maybe it crashes. And that's fine if you're interactively exploring a data set. It's not fine on a server. Yeah. Oh, what was the question? The question, is R Turing complete? Yes. Yeah. Yeah. Okay. So within the R world, you can wrap stuff up in a module and distribute it that way. And they actually have a pretty nice module system. If your code is written in C but wrapped in R, it will be compiled on install and everything just kind of works. But that's within the R world. If that's not acceptable, you want to interface with the wider world, or you want more performance, then that's more difficult. So if you need to speed up R, one way to do that is to rewrite things in C++. Maybe rewrite the entire thing, or maybe strategically rewrite a hotspot. Yeah. Well, about a year ago, I looked into how can I speed up R? And I read all these papers on, well, sometimes if you reverse the order of these two things on a full moon, it might get 10% faster. And the only reliable way I know of to improve the performance of R is to remove it from R. And there's a couple ways of doing that. There's a C interface where you can call C or Fortran. There's a higher level interface throug++ this module called RCPP that gives you a very nice high level interface. You take in an R object and cast it to a C++ object, and it takes care of all the marshalling and reference counting and does all that for you. Or you could brute force something. You could run R on many servers. There's a package called Snow, simple network of workstations people use for just running R on many machines. Yeah, Scott.
So at some point, I was a math major in college. At some point, I would get smart enough. I don't know, I'm not a math major, but at some point, I would get smart enough that they would give me mathematics. At what point does someone get into statistics and then someone says, "Oh, you need to know R now"? Is that graduate level statistics?
No, I think for a lot of people, they learn R with statistics. From Statistics 101, here's a theoretical concept, and here is the R to implement it. Or at least some people teach it that way. In some settings, you may have a more theoretical class first. In fact, the class I'm teaching right now is a graduate class that does not use R, but the people in there had R as an undergraduate.
Is there a book you recommend for getting to know R from that normal Statistics 101 approach?
Right. So if you're wanting to learn R along the way, I guess the most common reference is a book by Venables. Ripley or Venables? I think it's Venables. It's a Springer-Verlag book. I forget the title, but it's one that a lot of people use. There have been a few books that come out lately. There's a book called R in Action from Manning. The motor trend plot that example came from that book. So R in Action would be a good one if you're wanting to learn R for data analysis and graphics. The quote about R having prickly syntax came from a book on machine learning using R. Now, it's not an R tutorial, it's a machine learning tutorial, but it kind of gives you a mini introduction to R and then shows you how to use that as you go. All right, well, thank you very much.